So we have here some liquid nitrogen in a dewar which is boiling away at minus 196 degrees centigrade. And the first thing I'm going to show you is just what happens, how things change as we cool them down. So I'm going to take a balloon and just dunk it in the liquid nitrogen. Because the balloon's hot, you can see the nitrogen boiling away and all this condensation coming off from it. And the balloon has now shrunk. As it warms up and the air expands again, the balloon gets back to the size it was. So the properties of things change very much as we cool them down with liquid nitrogen. Here I've got an electrical demonstration. You want to come a bit closer to catch the demonstration. But I've got a small black disc of a ceramic material called a superconductor, and that's sitting in this cup of liquid nitrogen. And I'm going to float a magnet on top of it. Now the magnet is the electrons in... Sorry, I'll start again. Inside the superconductor, it's the electrons in the superconductor that are being changed by the liquid nitrogen. When I put the magnet on top, you can see it floats above the superconductor like that, because the electrons in the superconductor won't allow the magnetic field to penetrate it. There's no loss in this superconductor, that's why we call it a superconductor. And that's why, as long as it stays cold, that magnet will sit above the surface, and you can see it spinning there, and it's just levitated on the top. If I give it a little push, you can see the springiness of the repulsive force in there. And this can be used to make, for example, trains with no rolling resistance or levitating bearings. A bunch of flowers here. Flowers, like our fingers, contain a great deal of water. I'm going to dunk them in this liquid nitrogen that's at minus 196 degrees centigrade. So in they go. Because the flowers are hot, that makes the nitrogen boil off. Now that they're nice and cold and frozen, and all the water is frozen, and so I can just flick the petals off. She loves me not, she loves me not.